For years in the data world, the mantra was always bigger, faster servers, more power. But what if that whole idea is kind of outdated? Today, we're diving into serverless data engineering. It's a concept that's quietly become the essential glue of the modern cloud. And that question, man, it really gets to the core of it all. I mean, just think about that for a second. Imagine a world with no more patching servers late at night. No more guessing how much capacity you need and over-provisioning just in case. No more panic attacks when a sudden traffic spike hits. That is the incredible promise we're going to unpack today.
All right, so to kick things off, let's get on the same page. Let's get crystal clear on what serverless actually means and why it's become such a massive deal in the data world. Now, the name serverless is, let's be honest, a little misleading, because of course, there are still servers somewhere. But here's the crucial difference, the absolute game changer. You don't have to manage them. The big cloud providers, AWS, Google, Microsoft, they handle all of that messy stuff behind the scenes. All you do is give them your code, and they make sure it runs when it needs to.
This approach just unlocks some incredible benefits. Your whole setup is fully managed, and it scales up or down instantly without you lifting a finger. But the real headline here, the part that makes the finance folks smile, is the billing. It's purely pay per use. This means zero, and I mean literally zero, cost for idle time. If your code isn't running, you are not paying a dime. Think about that. It completely flips the old model of paying for servers to just sit around and wait.
Okay, that all sounds amazing, right? But how does it actually work under the hood? Let's pull back the curtain and look at the basic architecture, which is actually beautifully simple. Everything, and I mean everything, starts with an event. Think of it like a signal flare. Something happens somewhere in your system. That event then acts as a trigger for a specific function, which is just a small piece of your code. Your function wakes up, does its job, and then produces an output. Maybe it writes to a database or calls another service. Event, trigger, function, output. That's the core loop. Simple as that. So when we say event, we're not talking about some abstract computer science thing. We're talking about real-world stuff. It's a new photo being uploaded to cloud storage. It's a user hitting the submit button on a form which sends an API request. It could be a tiny piece of data from a smart sensor, or heck, it could even be something as simple as the clock striking midnight for a scheduled job. These are the real-world signals that kick off our automated serverless magic. All right, enough with the theory. Let's see what this looks like in practice. We're going to check out how the major cloud providers are using these very concepts to build some seriously powerful data solutions.
You'll see that every single major cloud player is all in on this. For that function part we talked about, you've got AWS Lambda, Azure Functions, and GCP Cloud Functions. These are the engines that run your code. And to handle all the triggers and connect the dots, you've got orchestration tools like EventBridge or Logic Apps. So yeah, this is not some niche experimental technology. It is a core part of the modern cloud.
Let's start with a classic, and I mean an incredibly common use case, automatically processing files the moment they land in AWS.
This flow is it's so elegant. A user drops a CSV file into an S3 storage bucket. That simple action, the upload, is the trigger. It automatically fires off a Lambda function. The function's code then grabs that file, cleans it up, maybe transforms it a bit, and then sends the clean data off to a database or another service like AWS Glue. No servers, no maintenance, just an instant automated response. It just works. Okay, now let's pop over to Azure. They have this really cool tool called Logic Apps that's perfect for building visual workflows.
Azure Logic Apps bring this awesome visual element to the table. An incoming web request can trigger a workflow that you've literally designed with a drag-and-drop interface. That workflow can then call an Azure function to do some heavy lifting and then load the final result into a data lake. This makes it incredibly powerful for stitching together different systems, like connecting Salesforce to SAP without writing tons of custom code.
And for our third example, let's see how GCP uses serverless to power machine learning pipelines, which is a really cool application of this tech.
So check this out. An API request comes in carrying new data. That triggers a cloud function. That function instantly inserts the data into BigQuery, which is Google's massive data warehouse. And then, and this is the cool part, it immediately calls a machine learning model hosted on Vertex AI to generate a forecast right then and there. This entire ML pipeline, from data arriving to getting a prediction, runs completely on its own. No VMs, no clusters, just pure on-demand computation. Okay, so we've seen the what, the how, and the where. For this final section, let's zoom out to the big picture and talk about not only when to use serverless, but also what you need to watch out for.
Think of this table as your practical little cheat sheet. Need to react to file uploads? Lambda and EventArc are your best friends. Building a real-time API for a machine learning model? Cloud Functions are a perfect fit. Need to handle incoming messages from a service like Stripe or Slack? EventBridge is literally designed for that. You can see how serverless just shines in these short-lived, event-driven scenarios.
And this brings us to maybe the most powerful operational advantage. Zero. We're talking zero idle clusters just sitting there, burning through your budget. For a lot of startups and smaller teams, this can even mean zero dedicated infrastructure engineers needed just to keep the lights on. I mean, that is a massive enabler for getting things done fast.
But, and this is a big but, it is not a silver bullet. It's super important to understand the trade-offs. The pros are obvious. You get incredible scalability and huge cost savings. But on the flip side, you got to be aware of things like cold starts. That's a slight delay the very first time a function runs after being idle for a while. Functions also have time limits, so they're not built for super long-running, hours-long tasks. And debugging can be a bit tricky since you can't just log into a server. This is why for those really massive, heavy-duty data transformations, a traditional cluster might still be the right tool for the job.
And this brings us to the most important takeaway of all. If you remember one thing, let it be this. Serverless isn't here to replace your data pipelines. It's here to connect them. Think of it as the indispensable, intelligent glue for your entire cloud platform. It's the connective tissue that allows all your different services to react to events and communicate with each other seamlessly.
And that leaves us with a final thought. In today's cloud-native world, adopting serverless is pretty much a given. The real strategic question you should be asking yourself is this: what powerful new connections, what incredible automations, and what new data flows will you build with this amazing event-driven glue?